so the point to the last problem we did was not only to practice the product rule, but if you can simplify, simplify first. It was so much easier to simplify first than to use the product rule. But there will be times when simplification is not an option. And that is what we're going to see in the next problem. 4x squared times e to the x. It's a product. And we can't simplify it. We can't multiply out. So I have to use the product rule. No choice here. So I'm just going to rewrite the original function here. And so that's 4x squared, very explicitly e to the x. And so there's my first factor. There's my second factor. So using the product rule, plane first, derivative of the second, plus plane second, derivative of the first. Product rule. You do not have to show this step. Plane first, derivative second, plane second, derivative first. I'm going to show that step until I'm relatively certain everybody knows the product rule. Now just doing my derivatives, plane first, so don't write anything down. Derivative second, you just memorize that the derivative of e to the x is e to the x. Then plane second, derivative of the first, 8x. And there is my unsimplified derivative. Now just doing a couple steps of simplification, I think the 8x looks prettier in front of the e to the x than behind. And it's multiplication. I can multiply in any order that I want. And then notice this guy factors. Both terms have a 4. Both terms have a factor of 4. Both terms have a factor of x. And both terms have an e to the x. And so I can factor out a 4x e to the x. Had 4 factored out 4, so it's gone. Had x squared, took out x. Had x left behind. Had e to the x, took out e to the x. Up to the plus sign. Had 8, factored out 4. 8 divided by 4 is 2. Factored out the x, factored out the e to the x. And there's the simplified derivative. Now, do I care about this? Generally, no. I don't really care if you do funky factoring. Not that that factoring was particularly funky, but I don't particularly care about the factoring. I just do this because sometimes my math lab does. Now, I wouldn't care if you made your answer match like that, but a good hint about my lab math, not because this wasn't particularly hard, a good hint is, there's view an example most of the time. Try not to use view an example when you're doing your homework, because that doesn't help you learn. But one thing view an example is good for is see how they answered the problem, and whatever format they answered the problem in is probably the format you should attempt. So if you've already looked ahead and seen that they factored, well then it's just not a big issue to go ahead and factor on the end to save you the time of, okay, I had the right answer, I'm going to do everything else, and then I'm going to remember to write Mrs. Brazelton and have her credit this back. That if it's a simple case like this, just go ahead and do it. It's the more complicated simplifications that I'm worried about. These simpler ones, make the computer happy, go ahead and do it. Now on a test or quiz, I'd be perfectly happy for this. My gut feeling is this is what my math lab would want, and it'll save you a little time just to try to match it. But if you've got it all done otherwise, you can write me and say, I think I have it right, but it just isn't simplified enough. I'll look at it, and if I agree, I can adjust your score. But the main point on this one is this one had to be done with the product rule. There was no choice. Okay, our last major rule, the quotient rule. And there it is in symbols, the derivative of f of x divided by g of x is g of x, f prime of x, minus f of x, g prime of x, all over g of x quantity squared. Again, somehow you have to memorize it. I'm just going to refer to the numerator and denominator. And kind of cutting to the chase, it says this: plain denominator, derivative of the numerator, minus plain numerator, derivative of the denominator, over plain denominator squared. You've got to know the quotient rule. There is no getting around needing to know the quotient rule. Now, if you've had calculus before, some of you may know the phrase low D high, high D low. And if that works for you, I'm okay with it. I just don't like it because I have to stop and think about the order each time. Because order is very important in the quotient rule. There's a minus sign in the middle, which means if you get the order wrong in the numerator, the problem is wrong. That wasn't an issue with the product rule. Product rule, there's a plus in the middle. So if you permuted these two, permuted this guy around, doesn't matter, it's plus. You can add in whatever order you want. You can't subtract in whatever order you want. So order makes a difference here. And again, not a small error. That if you get the order wrong, you're giving the opposite of the answer. And if you're doing something for your boss and you give the opposite of what the answer is, that is bad. So let's do this first one. Quotient rule. And there really isn't any other good option. Someone, you'll talk to someone and say, oh, you can live without the quotient rule. You can do this. Someone will tell you to do this. That they'll say, oh, you don't have to use the quotient rule. That you can do this. That is true. But this is a much harder problem. This is a harder calculus problem. That's not how you spell calculus. So don't do that. It's not that that's untrue. That's a true statement. But that makes for a harder calculus problem. There will be one time where you do want to do that, but this isn't it. This is a harder calculus problem. So we are just going to use the quotient rule. Don't do that. It makes the problem harder. And it's not going to give you the pretty answer that the quotient rule will give you. And I want the pretty answer. So let's do the quotient rule on this guy. Plain denominator plain denominator, 4x cubed minus 5, not 2. Derivative of the numerator minus plain numerator, derivative of the denominator, all over the plain denominator squared. Plain denominator, DEN, denominator, derivative numerator, NUM, numerator, plain numerator, derivative denominator, plain denominator squared. You don't have to show that step. Again, that's me trying to teach everybody what the quotient rule says to do. You don't have to show that step. Now actually doing it. Plain denominator. So don't do anything. Derivative of the numerator. Derivative of e to the x is e to the x. Derivative of 2 is 0. You obviously wouldn't have to write that plus 0 there. Then plain numerator, so don't do anything. Derivative of the denominator, 12x squared multiplied by the exponent, decrease the exponent by 1. After that 5, 0, and you wouldn't have to write the 0, all over plain denominator squared. And the above is the unsimplified derivative. Doing the quotient rule. Now we are going to simplify. When simplification is just a matter of multiplying out and combining like terms, we are going to simplify. To simplify, multiply out numerator. Nothing cancels initially. Is that how you spell initially? Yeah, I think it is. Nothing cancels initially. Yet, a good 1/3 to 1/2 of the class are going to cancel those guys. And that is just wrong, and I will punish you harshly for it. In a fraction, you don't cancel just term-wise. It's everybody or nobody. And since there isn't a 4x cubed minus 5 over here, nothing cancels. In 99% of the quotient rule problems, the way you're going to simplify is what I've said there. Multiply out the numerator and then see what happens. Okay, so multiplying out the numerator, I of course don't need that 0 there. And so I'm going to get 4x cubed e to the x minus 5 e to the x. Same thing there, multiply out the numerator. Be careful with that minus sign. We'll come back on the next step and get the minus sign. So minus 12x squared e to the x. Put that line in the wrong place. Plus 24x squared. All over 4x cubed minus 5 quantity squared, which gives me 4x cubed e to the x minus 5x e to the x minus 12x squared e to the x minus 24x squared all over 4x cubed minus 5 quantity squared. And there, hopefully, if I didn't make any mistakes, is my simplified derivative. Now, because I don't have a classroom full of people here telling me when I made a mistake, I don't guarantee my answers here. If you're watching these at home or wherever you are and you see a mistake, let me know, and then I'll redo the whole shooting video. Try to correct my mistakes. But there I did it with the quotient rule. And that was my only choice. And then big thing about simplifying, 99% of the time, you're going to multiply out the numerator and see if you can do anything in the numerator. 99% of the time, you're not going to end up canceling anything. We'll end that video here.